Model deployment basics in ML workflow. Model deployment basics in ML workflow. AI beginner level. Introduction. After building and evaluating a machine learning model, the next step is model deployment. Model deployment is the process of making a trained machine learning model available for real-world use. A machine learning model is not useful if it only runs inside a notebook or training environment. Deployment allows the model to serve predictions to users, applications, or systems. Model deployment is used in many real-world AI applications such as recommendation systems, fraud detection systems, spam filtering, voice assistants, autonomous vehicles, customer support chatbots. Understanding model deployment helps beginners learn how machine learning models become real AI products. What is model deployment? Model deployment is the process of integrating a trained machine learning model into a real-world application so it can make predictions on new data. In simple words, model deployment equals putting a trained model into production. Example concept. Trained model means application means real-world predictions. After deployment, the model can start making predictions for users or systems. Why model deployment is important. A trained machine learning model inside a development environment cannot help users. Deployment allows the model to interact with real data and real applications. Example concept. Trained model means deployed system means real-world value. Model deployment helps organizations automate decisions, improve services, analyze real-time data, power AI-driven applications. Without deployment, machine learning models remain research experiments instead of useful tools. Basic model deployment workflow. The deployment process typically follows several steps. Example concept. Train model. Down pointing arrow. Save model. Down pointing arrow. Build prediction API. Down pointing arrow. Deploy to server or cloud. Down pointing arrow. Receive data. Down pointing arrow. Return predictions. This workflow allows the model to work inside real software systems. Saving the trained model. Before deploying a model, it must be saved so it can be reused later. Common formats include .pkl, pickle, joblib, H5. For deep learning models, ONNX. Example concept. Trained model means saved model file. Saving the model allows it to be loaded and used by applications. Loading the model for prediction. Once deployed, the application loads the trained model to generate predictions. Example concept. Saved model means load model means generate predictions. This allows the system to predict outcomes using new input data. Model deployment using APIs. One common way to deploy machine learning models is through APIs. Application programming interfaces. An API allows applications to send data to the model and receive predictions. Example concept. User input means API means ML model means prediction response. For example, a mobile app sends user data. The server runs the ML model. The server returns the prediction. Popular frameworks for ML APIs include Flask, FastAPI, Django, Spring Boot. For Java-based systems, batch versus real-time deployment. There are two common deployment methods. Batch deployment. Predictions are generated periodically for large datasets. Example: daily sales forecasting, weekly customer analysis. Example concept: large dataset means scheduled predictions. Real-time deployment. Predictions are generated instantly when new data arrives. Example: credit card fraud detection, recommendation systems, voice assistants. Example concept: user request means instant prediction. Real-time deployment is common in modern AI systems. Cloud deployment. Many machine learning models are deployed using cloud platforms. Popular cloud services include Oz, Amazon Web Services, Google Cloud, Microsoft Azure. Example concept. Local model means cloud server means global access. Cloud deployment allows models to scale and serve many users. Monitoring deployed models. Deployment is not the final step. Once the model is running in production, it must be monitored. Example concept. Deployed model means monitor performance means improve system. Monitoring checks. Prediction accuracy. System performance. Data drift. Model bias. If performance drops, the model may need retraining. Model retraining. Real-world data changes over time. This phenomenon is called data drift. Example concept. New data means retrain model means improved predictions. Retraining helps keep the model accurate and relevant. Example Python code. Example saving a trained model using scikit-learn. Import joblib. Saving a model. Joblib. Dump. Model. Model.pkl. Loading a model. Model equals joblib. Load. Model.pkl. These commands allow the trained model to be reused in deployment. Real-world applications. Model deployment powers many AI systems used every day. E-commerce. Product recommendation systems. Finance. Real-time fraud detection. Healthcare. Disease prediction systems used by doctors. Transportation. Self-driving car decision systems. Marketing. Customer behavior prediction. Concepts learned from model deployment. Understanding model deployment helps beginners learn. Checkmark how trained models become real applications. Checkmark how APIs allow systems to use machine learning models. Checkmark how predictions are generated from user data. Checkmark how monitoring keeps models accurate. Checkmark how retraining improves deployed models. Deployment connects machine learning models to real-world systems and users. Simple definition. Model deployment. The process of integrating a trained machine learning model into an application so it can make predictions on real-world data. Final summary. Model deployment is the stage where a trained machine learning model is integrated into real-world applications. The model is saved, loaded into a system, and exposed through APIs or cloud services so it can generate predictions using new data. Deployment allows machine learning models to provide real value by powering AI systems such as recommendation engines, fraud detection systems, and intelligent applications. Understanding model deployment is an important step in learning the complete machine learning workflow.